One more caveat to our properties of complex logarithms has to do with complex powers. And so with complex powers, what we're going to do is we want to be able to define things like a to the b, where a and b are complex numbers, but we also want to do it in a way that this definition is going to agree with what we mean by a to the b when a to the b are real numbers, right? That's one of the complications here of complex analysis, is that you can define things however you want, but you want to define them in a way, such as looking at e to the z. You want to define everything in a way so that when z is a real number, everything works out the way that we're used to it working out, right? You get the usual functions, the usual values. So we want to define complex powers in such a way that when a and b are real, we get something that's already familiar. We know how to define powers of real numbers already. And so what we're going to do is we're going to define a to the b. We're going to think about a as being e to the log a to the b. And what we're doing here, and this is slightly subtle, is that in order for a to be equal to e to the log a, we've implicitly already decided on a branch that we're using, maybe the principal branch, maybe from pi to 3 pi, whatever. But a equals log of a only makes sense when we're talking about a specified, something that we've ahead of time already specified a branch. Okay, so we're kind of already assuming that we've specified a branch, and then if we do that, then a is e to the log a on that particular branch, where we do the exponentiation and logarithms in the usual way, according to whatever branch cut we've determined. Now, once we have that branch cut, then everything's fine. You got a to the b is e to the log a to the b, which is e to the b log a. So for example, if we wanted to look at what's I to the I, well, I to the I is just going to be e to the I log I. And let's use the principal branch from negative pi to pi. Okay, so let's say that that's our principal branch. And then this is going to be e to the I. Well, log of I is going to be the natural log of the modulus of I plus I times the argument of I. And so I, the argument of I is going to be pi over 2. The modulus of I is 1. So this is e to the I times 1 plus I times pi over 2. And then we can multiply through by I. And this is going to be e to the I minus pi over 2. So this is going to be, let's see, e to the minus pi over 2, whatever that is, times e to the I. And if you wanted to do this one step further, this is e to the minus pi over 2 times cosine. So you know e to the I theta is cosine theta plus I sine theta. If our theta is 1, we get cosine of 1 plus I sine of 1. Okay, and so that's what it turns out I to the I is if we make the decision that our branch was from negative pi to pi.